Welcome to volume day 2. Today we're going to discuss the volume formulas for cones, pyramids, and spheres. Let's get started. Similarly to the formulas we had yesterday, all of our formulas today are going to involve the area of our base. So for a pyramid, depending on what kind of pyramid you have, we can have a triangular pyramid or a square pyramid or a base pyramid. So you're going to find the area of that base using the formula from in class yesterday. And since it's not the same shape the whole way to the top, it kind of gets smaller. We incorporate this 1/3 to account for that. But then we have that height aspect like we did yesterday. So the formula for a pyramid is 1/3 times the area of the base, again whatever that base is, times the height of the pyramid. For the cone is always going to have a circle as its base, so we know the area of the circle is pi r squared. Again, that circle gets smaller as you move up, which is what the 1/3 accounts for. So for the formula for the volume of a cone, it is 1/3 times the area of the circle times the height of the cone. And then finally for our sphere, we have circles that kind of start from our middle and get small as you go up either way. So the area of the circle is again pi r squared. And then this 4/3 and r cubed account for that changing in those circles. So for our formula for the volume of a sphere, it is 4/3 times pi r cubed, giving us the three formulas for today. For our first example here, we have a pyramid. So the formula for our pyramid is that the volume is equal to 1/3 the area of the base times the height of our pyramid. So for our base, we have a rectangle, and the area of that base is going to be length times width, or in this case, 10 times 8. So for our volume, it's 1/3 times our area of the base, 10 times 8, and then we're going to incorporate the height of our pyramid, which in this case is 6 inches. So we multiply by 6. Once you have calculated all of that, then you get a final answer of 160 inches cubed. So here we have a cone, and the volume for a cone is equal to 1/3 times the area of our base, which in this case is a circle, so pi r squared, times the height of the actual cone. So for our values here, we have 1/3 times pi times 2.1 squared times the height of our cone, which in this case is 6. And we're going to calculate all of that. And if we round our answers to 2 decimal places, then we get approximately 13.85 centimeters cubed for the volume of that cone. For our next example here, we're given the diameter, so we have to kind of account for that. Again, our volume formula is the same. It is 1/3 times pi r squared times h, but we have to calculate what r is. So since the diameter is 13, we divide that by 2 to get 6.5. Plugging our values in, we now have 1/3 times pi times 6.5 squared times the height, which is 32. And then when we multiply all of that together, we get our answer, which is approximately 217.82 inches cubed. For our sphere here, our volume formula is equal to 4/3 times pi r cubed, so in this case times pi times 10 cubed. Not a lot to do here, let's go ahead and plug it into our formula, and when you do, we get approximately 4,188.79 inches cubed. Looking at our next example, again we should notice that we have the diameter here, and for our formula we need half of that, we need the radius. So for our volume, it's going to be 4/3 times pi times the radius, which is half of 11.9, or 5.95 cubed. Again, not a lot to do here. We go ahead and plug it in, and you get approximately 882.35 centimeters cubed. Here we have a composite shape, which means it's made up of more than one solid. And one thing we want to try and do here is break it up into 2 easier shapes. So I'm going to draw a line here, which will give me 2 rectangular prisms. And once I've done that, I want to try and relabel things. If I know that this height here is 40, and this is 60, then the difference is 20, which is this height here. I also know that this whole thing is 80, and this is 60, which makes this 20 as well. So now I have enough information to find the volume of my 2 different rectangular prisms. For the lower prism, we'll do that in black here, we have 80 by 10 by 20. So the volume of that lower one is again 80 times 10 times 20. And we get a total of 16,000 millimeters cubed. For our second one, this upper rectangular prism, we have a 20 by 40 by 10. So 20 times 40 times 10, which gives us a total of 8,000 millimeters cubed. So then for our final answer, we're going to combine those two, the 16,000 and the 8,000, to get a total of 24,000 millimeters cubed for our solid. For our final problem here, again we have a composite solid. So we have the rectangular prism on the bottom, and then we have our cylinder on the top. To find the volume of that rectangular prism, again it's the area of our base, which is 7 times 3 times our height of 5. So the volume is, again, 7 times 3 times 5, which is 105 centimeters cubed. For our cylinder up there, the volume is going to be area of our base, which is pi times r squared, so pi times 4 squared times the height. And that turns out to be 100.5 centimeters cubed. For our final answer, we just want to combine those two measurements to get a total volume of 205.5 centimeters cubed. Okay, that completes it for our volume formulas. Go ahead and start the homework.